All right, everybody. We're going to be talking about spheres here, their surface area, their volume, a little extra definition, and then we're going to go through some of these examples. So let's start right from the top with the surface area for a sphere. How much space is on the surface of a sphere? We have a formula for it, and that formula is going to be 4 times pi times r squared. And that is how we get the surface area for a sphere. Volume for a sphere is going to be 4/3 times pi times the radius to the third power. To enter third power on your calculator, there are a few different ways that the buttons end up looking to be able to do that. Sometimes calculators have a caret button, which helps out. And you'll want to look for whatever it is. Ask for help with a neighbor, or you can always ask me if you need to figure out what button does that for you. And then a hemisphere is half of a sphere. The surface area for a hemisphere is going to be half of the, well, let me just say what it is. So surface area for a hemisphere is going to be 2 pi r squared. In other words, half of the outside. But additionally, we're going to have this circle here in the middle exposed, so we're going to have to add in pi r squared, which if you add 2 pi r squared plus 1 more pi r squared, you end up with 3 pi r squared. So you may not think about it, or it may not make too much sense unless you think about the fact that there's this circle here on the surface when you only have half of a circle. You have that middle part exposed. But the surface area for a hemisphere would be 3 pi r squared. The volume is just going to be half of the volume that it already is. So 1/2 of 4/3 pi r cubed. Because it is half of the volume of the old one. All right. So, examples. Find the surface area of the sphere. The surface area equation is 4 pi r squared. Radius is 8. So we're going to have 4 pi times 8 squared. 4 times 3.14 times 8 squared. And we get 803.84 inches squared. First example done. Next example. The surface area of a sphere is 20.25 pi centimeters squared. What is the diameter? So, we're told what the surface area is, and we know that the equation for surface area is 4 pi r squared. So, the first good step that we could do is let's divide both sides by 4 pi. The pi's are going to cancel out on the top and the bottom over here. So now we just have to do 20.25 divided by 4. That gives us 5.0625 equals r squared. To get the radius, we'll take the square root of that. And we get that the radius is 2.25. To go from the radius to the diameter, which is what the question is asking for, we just double this, and we get 4.5 units will be centimeters. So there's that example. All right. A soccer ball has a diameter of 9 inches. Diameter right in the middle of the circle, or in the sphere, is 9, which means that the radius is 4.5. We need its volume. Volume of the sphere is going to be 4/3 pi r cubed, which in this case is going to be 4/3 times pi times 4.5 to the third power. So I'm going to do 4 divided by 3 first. Gives me 1.3 repeating, times 3.14, times 4.5 to the third power. And I end up getting about 381.51 inches cubed. All right, last example. Find the volume of this composite solid. So, just to clarify what's going on here, this is kind of like a bowl of sorts. This hemisphere, this half circle, is removed from this cylinder. So a good approach to this problem will be to find the volume of the cylinder and then subtract the volume of this hemisphere. So, the volume of the cylinder is going to be area of the base times the height, which in this case is going to be pi times 2 squared times 2, 2 being the height. So 3.14 times 2 squared times 2. And that gives us 25.12. Oops, 25.12. Okay. So, now we need the volume of the hemisphere. Remember, it's just going to be half of the volume of what the whole sphere would have been. So, we'll have 1/2 of 4/3 pi r cubed. R in this case, again, being 2. So, 0.5 times 1.3 repeating times 3.14 times 2 to the 3rd power gives us, in this case, 16.75. So now we just need to do the subtraction. 25.12 minus 16.75. And that gives us about 8.37 inches cubed. So, this is the third video in which you've seen one of these problems where you had to sort of combine two shapes together, or, deal with them as one unit instead of separately. So, hopefully, you're getting a little bit of an idea on how to do that. That's it for this video. Thank you for watching. Be sure to check my YouTube channel, and be sure to check my playlist for this, all these volume and surface area problems. I'm going to be finding some videos that help explain why some of these formulas work, especially the ones towards the end that I didn't cover in the videos. So, keep an eye out for those. Thanks for watching, and again, hope you learned something here.